frequency of the input. Whereas in peaking amplifier, when your signal has frequency F3, at that time only you get the highest frequency. Otherwise, your frequency is lower than that of F. Okay. So in the speaking amplifier, just you draw this circuit and in 2 or 3 lines explain the difference between the schematic amplifier and peaking amplifier. Draw this response, and the formulas are given for AF. It is minus RF in parallel with RP divided by R1. Why it is minus not a minus RF by R1? Because we have here parallel tube tank circuit. So this RP is the equivalent parallel resistance of this tank circuit, and the value of RP is Q coil square R. Just you explain this one. And Q coil, it is the figure of merit of the coil, and the bandwidth of this amplifier is Fp by Q, where Qp it is Rf parallel with Rp divided by XL. Just you will write down this whole formula, draw this waveform, draw this frequency response circuit, and in the full line you explain the work. That is enough for the speaking amplifier. Is it okay? What is the difference between peaking amplifier and inverting amplifier?
Yes.
So I am not going. The next topic is summing, scaling, and averaging amplifier. Okay, I think all of you have done it in your lab system, so we are not going in this topic. Go through it yourself. Very easy. So shall we go with instrumentation amplifier?
Yes.
Okay. So basically, what is the requirement of instrumentation amplifier? Suppose we consider any plant in which you have to maintain the temperature of boiler, or you are having some dairy plant where you have to maintain, let us say, constant minus 50 degrees Celsius, or in some application you have to maintain the pressure of some device. At that time, what we are doing, we are using transducer to measure this non-electrical energy, whether it is pressure or whether it is temperature or whether it is light energy. So by using appropriate sensor, we sense this non-electrical energy and convert it into electrical energy. Now, what is the use of this instrumentation amplifier? Whenever you use the instrument transducer, the change in the parameter, if it is resistive transducer, then the change in the resistance is very small, and you cannot detect it with simple your multimeter or any other device. So what we are doing to measure the small changes take place in the transducer, we are using instrumentation amplifier. What is the role of this instrumentation amplifier? It senses the small changes in the output, and with this, by noting the small changes, you can drive your measuring device, or on your measuring device, you can directly you can calibrate your measuring device to get the output which is proportional to change in the output of measuring device by which you can get the reading of your output. Okay, and at the input stage, we are giving the physical quantity which is being to be quantity which is to be measured. आपको temperature measure करना है तो use the appropriate transducer which can measure the temperature. If you want to measure the pressure, use the strain gauge. Okay, so depending on the physical quantity, you select the appropriate transducer, give the output of the transducer to the instrumentation amplifier, and output of the instrumentation amplifier is given to the ED. Okay, so here in your textbook, for example of instrumentation amplifier is given with the help of resistive transducer. So, do you know any resistive transducer? मैं ख्याल से कोई resistive transducer have you ever used?
Ma'am, idea?
It is okay. It is also resistive transducer. Anyone else?
Moisture sensor, resistive moisture sensor.
Yes, resistive moisture sensor. Okay. So basically, what happens in resistive transducer when the physical quantity is being changed, the resistor of the transistor resistor of the transducer is going to be changed. Okay. So what we are doing here, we are using here Wheatstone bridge. I think in measurement we have performed the practical of Wheatstone bridge. Have you done it?
Yes, ma'am.
Okay. So what is the use of Wheatstone bridge?
To find out the unknown.
Yes, to find out the unknown resistance. So what we are doing in Wheatstone bridge, in 3 arm of the Wheatstone bridge, we have the known resistance RA, RB and RC. Okay, and this in the 4th arm, the resistive transducer is connected. Which one is your resistive transducer? Is it AC bridge or DC bridge? Wheatstone bridge is AC bridge or DC bridge? Yes, it is DC bridge. Okay, whereas Maxwell, Hayes, Weens, all are the AC bridge. Okay, so here we have the to operate this Wheatstone bridge, we require the DC supply, and here your let us say I have measured here one multimeter, then my output is 0. Okay, so in Laplace condition or when this resistive transducer has no pressure given, at that time my VA is equal to VB. And if I apply this, what is the formula for VA? VA is RA plus RT into VDC. Again, potential divider rule. Student, are you getting me or not? It is
Yes.
RA plus RT into VDC. Okay, so it is RA plus RT into VDC, and same way VB is RB plus RC into VDC. If you simplify this one, you will get this balance condition for a Wishlet bridge. Product of resistance of one pair of opposite arm is equal to product of resistance of another pair of opposite arms. Okay, so now what we are going to do? Now I am going to give some pressure on the strain gauge. So what will happen? This resistance of this transducer is going to be changed. And now let us say this resistance is RT plus some delta R. Let us say earlier it is 120 ohm and now it is changed by only 2 ohm. So what will happen? My resistance becomes 122 ohm. So is it my bridge remain in balance condition, or it comes in the unbalanced condition? Are you getting my question or not? It will come in the unbalanced condition. So what will happen here? Now your VA is not equal to VB because your VA is RA plus RT, and now you have to consider now what is it? It is RA plus RT plus delta R into VDC. Okay, this is your VA, and your VB is RB plus RC into, this is your VAB, difference between this VA and VB. Okay, so now if you have here one submeter, then but see the change is only of 2 ohm. So your multimeter is not enough to measure the small changes. Only 2 ohm the resistance का change हो रहा है, so you are going to get a very small voltage VAB, and that you cannot measure with your simple voltmeter. So in this case, to measure this small parameter, we have to use the instrumentation amplifier. So in the first stage, we have this transducer. Now what we are going to do? We are, instead of connecting this meter which is not able to sense the changes, we are going to use
OPM.
instrumentation amplifier. So in instrumentation amplifier, what we do? We give this VA to one op-amp, where input is given at the inverting terminal, the non-inverting terminal. If my first op-amp A1, consider positive and negative supplies are given, and this VB it is also given another op-amp. Can anyone tell me what is the configuration of this op-amp A1? What is the name of this circuit? It is non-inverting, and we have already considered this circuit. What is the name of this circuit?
Voltage follower instrument.
Yes, it is voltage follower. Why it is voltage follower? Because in non-inverting amplifier, we have seen it is VO is 1 plus Rn by R1 into VE. Okay. So when you make your Rn 0 and R1 infinite, have differential amplifier using single op amp. R2 R1. Here we have R3 is equal to Rn. Now, here this output of first op amp. This is R1. Here we have Rn. Now, this is my differential amplifier using single op amp. And with the load resistor, we have connected here one indicator device. What is the use of this indicator device? It gives you the reading of the phasor quantity. Okay. So this A1 and A2 are the voltage follower, whereas this A3 it is differential amplifier. Are you getting me or not, students? What we are doing here? The output of piston bridge, it is given to voltage follower. This voltage follower work as a buffer which provides the impedance matching and avoids the loading effect of this third op amp. The configuration of A1 and A2 is voltage follower, whereas for the A3 the configuration is differential amplifier using single op amp. And in differential amplifier using single op amp, we have seen VO, it is minus Rf by R1 into voltage at the inverting terminal minus voltage at the non-inverting terminal. Remember, this is at inverting terminal, this is voltage at non-inverting terminal, as well as we have to make this assumption R2 is equal to R1 and R3 is equal to Rn. Then only this formula is applicable. Okay? So, what is here? Can you tell me what is the output of this A1 op amp and output of A2 op amp?
Okay.
Yes, it is VA and VB because both are the voltage follower. Okay? And then this output is given to the differential amplifier. So we are getting this output minus Rf by R1 into VA minus VB. So here, this is the formula for VA minus VB. This is VA minus VB. Okay? And if we simplify it, then it is, we consider this, all these resistors are of same value, let us say R. So it becomes R upon 2R plus delta R minus R upon 2R to BBC. Am I doing correct? Minus 2R delta R upon 2R plus delta R. Okay? So your VAB, it is minus delta R upon 2 into 2R plus delta R. So in the denominator, your 2R is higher than delta R because delta R is the change in the transducer resistance. of minus RF by R1. So in the op-amp, at the output, we are getting VO is minus RF by R1 into this VAB minus del R upon 4R. So it will be RF by R1 into del R upon 4R. Here we have VDC. So once your instrumentation amplifier is designed, can you tell me this output voltage depends on which things? તમે એક વાર instrumentation amplifier આખું ડિઝાઇન કરી દીધું તો આઉટપુટ વોલ્ટેજ VO શેના ઉપર ડિપેન્ડ કરે છે from this formula? What? Please pardon me.
From delta for the partially constant.
It depends on delta R because see what is delta R? It is the change in the transducer parameter, change in the resistance. Whereas your rest of the component RF, R1, R, VDC is not going to be changed. So we can say my VO is proportional to delta R. Okay? So what we are going to do here? In instrumentation amplifier, physically we calibrate this meter in terms of change in the resistance. Let us say मैंने 1 kg weight रखा weighing scale पे. So according to this 1 kg weight, I am going to get here some change in the resistance, and according to this change in the resistance, I am going to get this fixed output voltage. So for this voltage, let us say my indication is somewhat over here. Then here I mention it is 1 kg. Now I am putting another 5 kg. I am putting 5 kg weight, and let us say my deflection is over here. Then I am mentioning this indication as a 5 kg. So by using known weight, we calibrate our meter such that you will get the display in terms of the weight which you have put on the strain gauge. Is it okay how this instrumentation amplifier works?
Yes, ma'am.
You may ask this topic in the form of shortcut. So people this shortcut for 4 to 7 marks. Sometimes some examiner ask it for 4 marks and some ask it for 7 marks, depending on the weightage. Student, do you remember in how many times you have to complete one question? Have you completed the time? GTU exam, if your question paper is of 70 marks, so in 14, in half an hour you have to complete one question of 14 marks. So there are 5 questions. So give your timing as per the weightage of the marks. Sometimes it happens student take 1 hour to attend the question of 14 marks. So there are 5 questions of 14 marks, total 70 marks. And total time is 2.5 hours. So in half an hour you complete each question. So watch your keep watch on your watch and complete the question in half an hour. Not give more time than half an hour. Otherwise you may have chance to give the unattended question. Take care of the time during the exam. Now next is the most important point. It is integrator. Can anyone tell me what is integrator? Have you performed the practical of integrator? So in integrator, what is output voltage? Output voltage is the integration of input. Okay, that means आपने square wave input दिया, so what is your expected output? और let us say sine wave दिया, तो sine wave का integration क्या होगा?
Cosine wave.
Cosine wave मिलेगा. Okay, so basically in integration उसका आपको ट्रायंगुलर वेव मिलेगा और साइन वेव दोगे तो यू आर गोइंग टू गेट कोसाइन वेव. So in integration again it is a inverting amplifier. So what is the thumb rule to do the analysis of inverting amplifier or voltage and feedback amplifier? कौन से रूल अप्लाई करोगे आप? जो अगर I told you. Yes, first one is the virtual ground and second one apply KCL. Okay, आप ये दो चीज याद रखोगे तो you can easily derive the formula for output. Again you connect positive and negative symbol. So we are going to apply here KCL. Okay, so this is my input current, this is the feedback current, this is the IV current. Okay, so if I apply KCL at this node 2, then we can say I is equal to IM plus IV. What is I in current? It is VE minus V2 divided by R1. Whereas IV2, it is negligible because it is the current flowing through this 2 mega ohm resistance. Inside the op amp, the internal resistance is 2 mega ohm. So this IV2 current is negligible. We can say IE equal to IM. And what is the formula for IM? It is V2. Sorry, here we have to consider the current through the capacitor. So the current through the capacitor, it is C EVC by V2. Okay, and whereas what is the capacitor voltage? It is C into V2 minus VU. So it is VE minus V2 divided by R1 is equal to C derivative of V2 minus VU. And here if we consider the virtual ground concept, because in voltage and feedback amplifier, V2 work as a virtual ground, the potential at node 2, it is 0. So we can say it is VE by R1 is equal to minus C VO by VD. And get the formula of VO. I am going to take integration both sides. So VO is minus 1 upon R1. Therefore, we will use the subscript F. Feedback resistance, feedback capacitor. So use the subscript F for capacitor. So it is VO is minus R1 CF into integration of V. So what is the formula for the output? Output is the minus 1 upon RFC1 times integration of V. But here, this is the basic integrator circuit, which has certain limitation. So first, let us consider what is the limitation of the circuit, and before that, let us draw the input and output waveform for sine and cosine. Let us see first I am going to consider the square wave. second. Then when my input is plus 1 volt and due to this negative sign, I am going to get here negative going there and it is reaches